regarding join, we mentioned that we often use join when we need to access data from several tables, more than one table, right? Then we need to link those tables. And how can we do that in general? Using the foreign keys, right? So while most of the time you're joining tables using foreign keys, that is not always the case. We also showed an example of, for example, when we join tables using another common attribute and not foreign keys. So we have different types of join. Inner join, which is basically if you just use the two methods that we covered before. I don't have to write there. So we had inner join, right? Or join, just join, right? So both are same. And we have also outer join, which include left join, right join, and then outer join, right, which include left, right, and full out. So the important thing here is that when you use inner join or just join, or just using comma without explicitly mentioning join, for example, you write select star from table 1, comma, table 2, right? That is another way. And then where, for example, table 1, column 1, so this is something like this. Select star, right? From, let's say, table 1, comma, table 2, right? And then you have your join condition where table 1, column 1 is table 2, column 2, for example. And then this column 1, column 2, most of the time is the foreign key and primary key in another table, right? And sometimes, like in rare cases, it could be another common attribute. For example, in our example in the slides, we have the staff table and the organization table. They had two common attributes. One was the foreign key department number, right, which was the primary key in the organization table. So you could use join you could join these two tables, organization and staff, using department number. In that case, that was just a foreign key. Or they had another common attribute, which was manager ID, right? Manager ID was the same as the staff ID. Now, manager ID is not foreign key in the organization table, but it is just a common attribute, and you could use them using those common attributes. So this type of join, always return only the common values between the two tables, right? So and it doesn't include any null. For example, if we have consider the student registration example we used since the beginning of this course, if we have students who have not enrolled in any courses, or if we have courses for which we don't have, for example, instructors, things like that. So it means that we have some null in our database, right? If you just do inner join or join, it doesn't include in the results table, it doesn't include any of those rows, including null values, okay? Which means doesn't include students who didn't took any courses. It doesn't include instructors that do not teach any courses. It doesn't include courses that have no instructors, and so on. About other join, we have left join, right join, and full other join, right? And can we just simply write, for example, select star from table 1, left join table 2 instead of left other? Yes, because for inner we don't have left right, right? So we can simply write left join, right join. And what does that mean? So in case of left join, it means everything from the left table, even if the corresponding value in the other table is not, right? Now, if you have, for example, table 1, left join, table 2, which one is your left table? Table 1, right? So the one on the left side of the join. So this is your left table. Now, it means everything from table 1 even if the corresponding value in table 2 is null. Now, example in this slide, for example, we have select course code instructor name from course, left join or left outer join instructor on the comment field, which in this case is the foreign key, right? Using the foreign key because instructor ID in the course table is the foreign key. Now, what does it mean? What does it include? Does it include instructors who are not teaching any courses? No.
Yes.
No.
Or left.
Because instructor is the table on the right. I said instructors that do not teach any courses, which means for the instructors that the corresponding course value is null, right? So for example, you're writing select course code and instructor name, right? So in the result, you have course code, right? And instructor name. Right? For example, we have ECS 3421. We have, let's say, 4412, for which we don't have instructor. And then we have another instructor, I don't know, John, who is not teaching any courses. Now, when we use left join and considering table 1 here, considering we have, for example, select star from course, right? Then left join instructor. So in this case, course is the left table. So if you write from select the star from course left join instructor is different from when you write select the star from instructor left join course, right? So in this case, course is your left table. It means everything from the course table, even if the corresponding value in instructor is null. That means we include courses for which the instructor value is null in the case of left join here, right? So even if we have course that instructor is null, this is okay, right? But is it okay if I have instructors that are not teaching any course? No, it doesn't return those values, right? So this is not okay. So this is, for example, if you use left join between course and instructor, where course is the left table. Now the same thing if I write select star from instructor and left join course. Sorry for my handwriting. This is instructor, this is course, right? Now the left table is instructor, right? So this is different from the previous query. In this case, it returns everything from the left table, which in this case is instructor, right? Return everything from instructor, even if the corresponding value in the course is null. That means it returns instructors who are not teaching any courses, right? That the course value is null. So in this case, we can have, so this is course code, this is instructor name, right? And we have, for example, 3421 or not. This is okay because both values exist. If we have a course for which we don't have instructor, is this okay? No, because we set everything from the left table, even if the corresponding value in the course table is not. Here the instructor is not, so this is not okay. But for example, if you have an instructor that is not teaching any courses yet, in this case it's okay. Now this was about the left join. Is this clear? Yep. Like this? Yeah. Okay. So now how about right join? Very similar, just instead of left, now we are using the right table. So for example, if you're writing select star, if I write, let me be more here, star, I want to work on my handwriting, from course, right join instructor. Okay. Now it means everything from the right table. What is the right table here? Instructor. So everything from the instructor, even if the corresponding value in course is null, right? And you, of course, you also have on here, right? So you have your join condition on, for example, course, that instructor ID is, for example, I don't have enough space here. Also, instructor, right? Here we are joining using the foreign key. Now in this case, we have everything from the instructor, even if the course value is null. So can I say this is equal to, if I write select star from instructor, left join course, is this the same?
Yeah.
Yes, the same. The first one says right join between course and instructor, which means everything from instructor, even if the corresponding value in course doesn't exist. The second one, we write it just the opposite way. We select the star from course, instructor, left join course, right? It means everything again from the instructor, even if the corresponding value in course is not, right? So, and here we have instructor name, right? So again, values like these are okay, rows like these are okay, right? Now, right join is instructor, so we have everything from instructor, even if like the course code is null, right? And this is also okay. But for example, if we have a course that instructor is null, this is not. So, is this clear?
So if we include like the null where it's not supposed to be, is it gonna give like an error, or is it just not going to show that null?
It is not going to show.
Okay.
It doesn't, like for example, if you have the null values, right? What I want to mention is that if you have some, for example, courses for which you don't have instructors, right? It doesn't return any values for you. If you want to show everything, like returning all courses and instructors, even for courses that don't have instructors, and for instructors that are not teaching any courses, what do you use? Morning, full outer join, right? So just use full join. It includes everything. So in that case, if you use, I need another picture. So maybe if I get even more, if you have more pictures, I think I completed this 4-5 till the end of this session. So full outer join, then we return. Here you have course code. Here you have instructor name, right? And if you use full outer join, then you have, for example, something like this is okay. If this is null, you have instructor is not teaching this course is okay. If you have a course for which we don't have any instructor, is also okay. Okay, so this can be retrieved using full outer join. Now the inner join, or just the normal joins that we've used so far, that will only return this one. So we only return course code and instructor name, right? It only returns this value. Okay, this is inner. This is outer. So is this clear? Now these are the type of joins that we mentioned. We can also see these like in this slide. So inner join, it is not allowing null in the join fields and only return everything that matches in both tables. In left outer join or left join, returning everything from the left table, include courses that do not have instructors, if you write course left from instructor, right? And then right join include everything from instructor, even if the course is null, and full outer join return just everything. And then we discussed union. So we said union is combining the result set of two or more select statements. So the only thing that you have to pay attention here is that is the difference between join and union, right? So when you're joining tables, you're adding to the columns of your result table, right? So you are merging tables using their common attribute. You're not adding to the number of rows, right? Or the number of records you have. Whereas when you're using union, so you can see this example, this is for joining tables, this is for union, using union between two tables. Now you're combining data into new rows. So what are the conditions? So as the picture suggests, the two tables that you're using for union should have the same number of columns, right? Because the result of your query is always a table, right? So that table should have a fixed number of columns. You cannot have a table like this, right? You can't have a table like this. So let's say it start with this number of columns, and then at some point it has more columns. So this is not a correct table. So the two tables should have the same number of rows. And so this is an example. For example, listing all employees with less than 3 years, 3 years of employment, and applicants with more than 14 years education. So in both cases, we assume that these two tables have the same number of columns, and the data types are the same because from both we are using the years, right? Here is the years of employment, here is years of education, and so we can use union. So they must have the same number of columns, and the corresponding attributes must have the same data type. And that is obvious, right? You cannot have, for example, here, let's say in the column 1 is this is integer, you cannot continue it with a string or text or something else. Then we talked about correlation variables or self-join. So example was, for example, listing employees whose salary is greater than the salary of managers in the same department. So if you look at this query, everything you need exists in the staff table, right? But you are comparing values in the salary column between two different rows, again, in the same column, which is the employee ID, right? Now, employees or staff in your staff table, if you recall the staff table, they had different job roles. Some of them were managers, some of them were not managers, right? So we want to compare the salary of those employees who are not managers with the ones that are managers, right? And then only listing those that have higher salary than the managers in the same department. So this is the typical case of a self-join. So you can join staff table with itself. How can you do that? You can use aliasing. So give the staff name some name. Once as X, another time is Y. Why? Because you need to specify one of them for the normal employees or non-managers, and the other variable for the managers, so that you can compare, right? You can compare the salary of X, right, where X is not manager, with the values of salary for Y, which is managers, right? Is this clear? And then we had these queries, and so finally about any and all. So the any operator compare the value in each with each value returned by subquery. So what does that mean? For example, you want to list employees who work in Eastern Division. Okay. So what does this subquery return? So we have select department number from organization where division is Eastern. What does this subquery return? Yes.
Staff whose department number is in the Eastern Division.
Yeah, departments. This one, select only departments, right? In the Eastern Division, right? Now, the query asks us employees who work in Eastern Division. So it returns true if the condition is true for any single value here. So for any department, for example, let's say B10 division is Eastern, B20 division is Eastern, right? If there are like, let's say these two departments with division Eastern, then it lists all employees working in that department. Is there any other way to answer this query? So this is what it returns. So as you see, we have departments in Eastern Division. Those are B15, B20, and B38, right? And then we want to list employees working in that division, right? Or those departments. So is there any other way rather than writing this with any? Let's say I ask you list employees who work in Eastern Division. Anyone can answer that query with a bonus point. So I'm considering, let's say, so for the bonus point, I can write it on 4. So this is the bonus point for anyone answering this query.
You go back.
Okay, let me actually find a staff table. Okay, this one is the staff table, but I'm not sure if this is clear. So we have a staff ID here, staff name, department, job, years, salary, and commission. So this is the staff table.
Select the staff name and the staff ID. Staff, join, column, the board, then where the department numbers are equal,
Yeah.
and where or dot division is equal.
Yes, simply using join, right? So I included this here for you, just because I don't want to, I want to finish the slides today and then go to the hands-on with SQL. So just showing you the query. So one way, because I'm teaching any, I showed you how to write this using any clause, right? But you can actually, if you see this slide, as you can see this. So this one, all employees working in Eastern Division, and I included using join, so you can find employees working in Eastern Division simply joining staff with the organization. Why? Because division information is in the organization table, right? Staff information is in the staff table, so you can select staff name, job, department number. So far, everything from staff table. For division, because we need division, we also need the organization table. So from organization, join staff. What type of join is this? Inner join, right? And we don't actually have, I think, any nulls here, so it makes sense. And join them using the foreign key, right? And department number equal to staff department number, where division is Eastern. Just simply adding your condition that this division should be Eastern. Now, if you want to answer the same query using any, you can just write it this way, right? So first, this is my way. I first write the subquery, and then selecting those staff from staff table where the department is here. Because here is returning the department numbers in Eastern Division. And then we need, as long as our staff working in any of those departments, then it returns it for us. And you can see actually the result is the same, right? So the same stuff. And two other examples. So for example, this is for the correlation example. I again wanted to show you that there are more than one way to answer a query. So for instance, we had a question finding employees with higher salary than any employee whose job is safe. This is very similar to the example we had, finding employees whose salary is greater than their manager's salary, right? In that case, you were comparing with manager's salary. Here, you're comparing with the ones in the sales job salary, right? That's literally the same. So if you want to answer this query, one way is using the any, and another way is using correlation variable. So this is exactly the same as what we had before. So you select, for example, all the columns you want from staff, join the staff, right? You give it a name, X and Y, A and B, whatever you like, right? And then what is the condition? We want to compare X salary with Y salary. If X here, for example, is, let's say, a normal employee, and for example, X is those employees whose job is safe, right? And then Y is the others. And then you can compare them like this. Another way to answer this is using any. Here, select salary from staff where job is safe. What does the subquery return? Select salary from staff where job equal to safe. This is easy. What does it return? Yes.
Yeah, it's just like the salary of all the staff who are in sales.
Yeah, so it will be just one column salary, right? But only salary of those employees who are working as sales, in sales, right? And now what does the whole query return? So it select the staff with their salaries, but only those staff whose salary is greater than any of the results of this subquery. That means from any of, for example, those salaries that the job is safe. So let's say if there are two people in the staff table with job safe, okay? So let's say you have two people, and this is job, this is salaries, this is a staff, okay? Now, and this is sale, this is sales, okay? So let's say one is 18,000, one is 20,000, okay? So when we write select salary from staff where job is sale, it returns this, right? Now, and when we compare it with any, what does it mean? What do you expect? Which amount of salary do you expect to see in the result? Greater than 18,000 or greater than 20,000? 18,000. Because this is any, right? So it compares, right, these salaries, and as long as it satisfies at least one, right, at least one in the subquery, it's okay. So as long as the salary of the staff is greater than at least one of them, for example, at least 18,000, right? Then it returns everyone greater than, have salaries greater than 18,000, okay? Is this clear?
So it's the same thing like cut off the lowest salary.
Sorry?
So it's the same thing like cut the lowest salary staff out of the table.
Cut the rows?
Lowest salaries staff out.
Lowest salaries? Not lowest. It first find the salary of people who are working in sales, right? Let's say you have 2 employees working in sales with these salaries. Now we want to return only those employees whose salaries are greater than, right, any employees who are working in sales. Now the reason I'm emphasizing this is because after any, I'm explaining all. And most of the time, I see students confuse any and all. They want you to understand. Now that we are focusing on any, it means we want staff with salaries greater than any item returned by the stop query. Now the stop query returned this, right? And we want employees with salary greater than any of these items, right? So as long as it satisfies at least one item here, it's okay. So if you have a staff with salary, let's say 18,200, even if it is less than 20,000, it's still okay, right? Because it is greater than at least one of them, which is 18,000. But if you have a staff with salary like 17,000, is that okay? No, because it is not greater than at least one of the results of the software. And that is the meaning of N, okay? So again, for answering this query, we have two ways. You could either write it using any, or you could write it using self-journal correlation. And then all similar, with the exception that here it returns true if all of the subquery values meet the condition. For example, we want to find departments with highest average salary. Okay, so if you recall, the salary information is in the staff table, right? So in the staff, I need another paper, sorry. Anyone has maybe 2 or 3 papers to please give it to me, thank you. So in the staff table, we have a staff name, department number, right? Salary information. And if you want to find the department with highest average salary, it's a comparison, right? Between, so first of all, you have to find the department's average salary, right? And then finding the one with highest. So, anyone have a question? Thank you so much. Our staff table was something like this. Yes, we had staff ID, staff name, job, department number, salary, and so on. Right? And then because we have several staff, let's say, working in the same department, for example, let's say you have 10, right? With different employees, and then let's say 15, again with several employees. And here we have different salaries, right? Let's say 100K, 500, 25, 50, and so on. So, and please remember to give me your name. So if for all the queries today, if I ask you to answer the query, if you answer, I give you this bonus point, okay? And if you got the bonus point, just remember me at the end of the session. So, who answers this one? Finding departments with highest average salary.
Select department number, comma, average salary from staff. Having average salary greater than.
When do we use having?
If we have a group, like if we group by. If there's
So
an
we didn't
aggregate.
use any group by yet?
You use it after aggregate functions.
Okay, so in this case, we said we use having after aggregation, right?
Because we're grouping by department.
Yeah, so we need to group by also the department number. So selecting department number, average salary from staff, right? Group by department number, right? Because we want average salary in each department, right? So we need to group by the department number. So you select whatever column you want to return, let's say staff name and department number. Can I write this? and then from staff. Is this okay? Group by department number, and here we have average salary. Having, okay, you can continue with your condition and then tell me what is wrong here.
You can't put staff name because there's more than one staff in the department number, so you can't
Correct.
group by department.
Yeah, we cannot have staff name here, right? Whenever we use group by, our select statement is limited to only the column or columns we are using in the group by, right? And or any other column as long as they are using aggregate functions, right? So we can have, for example, average salary, minimum salary, and so on, but we cannot have salary itself. So having, yeah,
Average salary greater than
I'll give you the bonus point even if it's partially correct or if the logic is okay. So don't worry. So far you're okay.
greater than and then average salary with a nested query for all of them.
Yes, okay, this is what I wanted to hear, right? So we want to compare it with the nested query, right? Where we find the average salary of the departments, right? So far you are just finding departments with average salaries, right? So you group by department numbers, so you have average salary of the department. And now the condition is that we want to find the department with highest average salary, right? So having, and we said when we have group by, we cannot use where after that, right? Where, you use where clause before aggregation. So when you have conditions or you want to further filter the results of the aggregation, which is the case here, right? You use having. So we have having average salary greater than all of these subquery. Now, what does this subquery return? Average salary for each department, right? So let's say we have average salary 300K here, and we have average salary 200K here, right? So we have departments with average salary. So this is from the subquery. And then we want to return those departments, right? Which their average salary is greater than all of these, right? Not at least one. So we cannot use any, because if you use any, it returns any department. Let's say if you have D42 here and the average salary is 250K, if you use any instead of all, it returns even D42, right? But we want only the departments that have the highest average. So it should be higher than all of these. So this is what we mean by all. It returns true if all of the subquery values meet the condition. So I just showed screenshots of running this query on SSMS and then Azure. So for example, finding average salary for each department, right? This is easy. You should, I expect all of you to be able to write this. And then finding departments with highest average salary. This is just a query using all that we just included. Now, is there any other way? Is there another way to write the same query? Yes. So one way was using all. The other way is just using top, right? We've learned that. So this will be limit if you are using MySQL or SQLite. But in SQL Server that we use for this class, we use top, right? So we have, for example, top one department number, average salary from staff, group by department number. So forget about top. It returns if you don't have top one. What does the query return? Average salary for each department. And we want the highest. So we can simply use top, right? So it returned then top one. And don't forget to use order by, right? Because top one returned the first row, not max. Okay? It doesn't mean max. it depends on how you sort the data. Here, we order by average salary descending, which means we sort it from highest salary to the lowest salary, right? And so the first row or top one will be the one with the highest salary. That is why. So if you just write select department number, average salary from staff, group by department number, order by average salary descending, you will get just a list of employees with list of department with average salaries in descending order, right? So you have the same department number and average salary. Let's say your highest salary is 23,000, and then 20,000, and then 90, and then you have department split, right? So because we order by average salary in descending order, means from highest to lowest, and then you use select top one, right? Top one, select the first row. Now in this case, because the first row was we sorted in the descending order, it returned the highest. What if you want to return the lowest? The lowest salary? Yes.
Sort it in ascending order instead.
Yeah, you just change the order. Instead of using descending, you use ascending. In that case, your average salary, right? Average salary in ascending order will be starting from, let's say, 17,000, then 19,000, then 20,000, and then 23,000. And now if you use top one refers to this row, right? What if I write select top two, department number, average salary from staff, group by department number, order by average salary, ascend? Yes?
It's the two lowest.
Two
averages.
lowest, right? Because you sorted average salary in ascending order, which means from lowest to highest, and top two means top two rows, right? And so top doesn't necessarily mean max mean, it just means the first rows, right? And this is exactly similar with limit clause that you make using MySQL, okay? So in that case, if you are using MySQL, write select department number, average salary from staff, group by department number, order by average salary descending, limit, for example, the number of rows you want to return.
Isn't there a difference though between the first and second method in the case that like if two departments have the exact same average salary, like two share the place as the top average salary, then wouldn't method two only show one of them and method one would show both?
So the difference between all, using all and top, you mean?
Mm-hmm.
So the difference between any all versus, for example, using join or top, etc., in practice is mostly in terms of performance. In terms of performance, most of the case, like most developers, SQL developers prefer to use join, prefer to use top rather than using any and all. And the reason is because it's much faster, especially for large tables, because when you are using join, for example, then it doesn't, for example, using any and all, it compare every row of the subquery, right, with every row in the other query, which takes a lot of time. Whereas, for example, for joins, especially because we have primary keys and indexes on the tables, on large tables, it's much faster. It doesn't just compare like these much rows. And so this is almost like if you use join, it's almost faster, always faster. Now, back to your question, you said if you have two, let's say, departments with the same maximum
Yeah, so like
value,
if two of them were 23 grand each and then there was one 18 grand or something like that.
So I guess in that case, we have to, I'm not sure, I have to check that. Maybe I add a row, added another department with the same average salary. Because top one returned, for example, the first row. And then, that's actually a very good question.
Yeah, because for the first method,
Yeah.
1, 2 technically satisfied, so 2 would come up.
Yeah, if we have time this session, I just add another one and see which one works better. Maybe for top, I'm pretty sure it should return only one row because this works like a limit. But this one I'm not sure. We'll see. Now, this is just some points about views. For example, I already mentioned about views before. For example, creating a view sales as a list of all salesperson. How can you do that? Just write create view and the name of the view you want. So this is just a name with the columns, and then ask. So this is the syntax just to create a view. And you can use it the same way that we use tables for the query. So as soon as you create this view, let's say you create a view sale here, then you can simply use it like a table. For example, select the star from sale. It doesn't matter that this is a view, right? It's like a neutral table.